Hello, this is Dr. Hassan Abdullah with the course Complexity and Analysis of Algorithms. So, the supplemental website for this course is www.easymcq.com/goget. And the topic which we are covering is the basics, and within the subtopic is the brute force approach, which is like trying all possible possibilities and solutions. So, we'll talk about it. So, the course consists of 11 topics, and we are at the first topic. And just to give you a brief overview of the supplemental website, which is a learning management system which has these wonderful features and tools which will help you in understanding and in your assimilation of knowledge and your success in this course. So I would suggest and advise you to look at these 6 videos. So now we move on to the supplemental website. So instead of going through the main page, I have just moved to the Q&As which relate to the brute force. So what is brute force? Brute force basically is a problem solving approach. So what are the characteristics of this approach is exhaustive search. Exhaustive means they try all possibilities, and that can be computationally expensive also. But that we are just not doing it randomly, doing it systematically. Okay, following one by one, creating a solution, and then we create all possible solutions and we check them to find the correct solution or the best solution or the optimum solution. And it's a fairly straightforward approach. There's no complexity here, and without employing any heuristics or shortcuts, just try all possible solutions. So what are the characteristics is that it tries all possible solutions, and it is not the most efficient one because it is heavy on the computational resources. But when all possible solutions are considered, it ensures that nothing or no stone is left unturned. It means that the solution is going to be found. It is going to be found. It's not there is a discovery here. So it's very simple. It's to understand. It is easy to implement, easy to code, and it is easy to maintain. And just a couple of loops, and the solution is guaranteed since all possible solutions are tried and they are checked. So it will always find the correct solution as long as one solution exists. But having said all of this, it does not work for large input sizes because of the computational inefficiency. For example, it may take exponential time to solve combinatorially complex problems. And this what is this picture is showing basically is that if you don't have the key and you have the strength, so maybe you left your key inside your house or you dropped it, so you enter your house and you are strong enough to break into your own house. So that is the brute force approach. And if it is not done properly, you may actually end up breaking your bones also. So if you want to know more about it, here are the references. And examples of brute force approach for searching unsorted list and the traveling salesperson problem, which has been attracting a lot of attention for a while. And so searching for an element in an unsorted list. So we will study in binary search. If the list is sorted, then finding the whatever you are looking for, that takes order log and time. But if the list is unsorted, then it's an exhaustive approach. Exhaustive approach means that you check the first element. Is this the one which you wanted? No. Check the second one. Is this the one you wanted? No. You keep on doing this. Maybe on an average you find it in the middle. So the time complexity is order n, or may you may end up the finding it at the last one, or you may not actually find it. So that's an exhaustive approach. So maybe you go to maybe for example to a skyscraper and you're looking for somebody, and you end up checking all the rooms, which is not possible. You may not be allowed to go to certain floors and knock on certain doors, but that is the exhaustive approach. So the time complexity is order n. In the case of skyscraper, it is the total rooms available over there. Then looking at the traveling salesperson problem, that is more challenging, and the time complexity is order n factorial, which approximates to about order n power n. So how does it works? Start with the first element and you compare it with the second element. Okay, that was the for that sorted list. I'm sorry, that was for the unsorted list. Now the traveling salesperson problem generate all possible routes or permutations. So if I have like 10 cities, so 10 points to visit within a city, I generate all the permutations, which is 10 factorial, which is a very large number. You can do it on your calculator, on your phone, and calculate the total distance for each route or route. Okay, you add up the distances and you find the minimum one, right? So the time complexity is order n factorial, which is very large. And this is an example of simulated annealing, which I mentioned in the first part of this topic. So we can see that there are quite a few cities over here, and this is actually a snapshot of a simulation. If you are interested, you can check this link over here. So this is a better solution here. The total tour length is about 40, and this is about 7.6, which is like about 6 times better, 600% better. So this simulated annealing approach basically cuts down on the search time, and you can see that the time taken is also you look at the iterations, 57,000 iterations over here, and 39,000, about 40,000 iterations here. So brute force has its own merits and demerits and depends upon the application domain. So the next question is that when is brute force approach used for problem solving? When the problem size is small. So for example, 5 factorial is I believe 120, but 10 factorial is way larger, and 20 factorial is way larger, right? So when the problem size is small, then it is feasible in terms of time and resources also to try all permutations, or to try all possible combinations to the input and so on. And of course that time is manageable because the problem size is small. Guaranteed correctness is required. Brute force guarantees that all possible solutions are tried and no stone is left unturned. So when the correctness is of the highest priority, okay, and then of course brute force is applicable, but you need to have very strong computational resources, powerful. Lack of efficient algorithms. Algorithms do not exist. Proven algorithms do not exist. For example, we will cover the second last topic, which is theory of NP-completeness. So we either have the option of going with inaccurate solutions or approximate solutions, or we use the brute force approach and get the exact solution. Verification and testing are often used as a baseline for comparison when verifying more optimized solutions. So this is a kind of a golden standard or the gold standard, and we compare it the solutions which are produced by other known algorithms. So this is another application domain. So what are the drawbacks of brute force problem solving approach? Inefficiency. These algorithms are very inefficient. Why? Because the time complexity, it is an exhaustive approach, try all possible solutions. They can take very long time. Theoretically, they can take years, and for large input sizes become impractical. And for example, the input size for a reasonable, it is not feasible. Example is traveling salesperson problem. I mentioned number of times. High time complexity, it is non-polynomial. It is exponential. It can be to order 2 power n. For example, we have a combinational circuit, and it has n inputs. So the question is that which set of inputs is going to produce the truth value of 1. So the only way possible is to try all possible of them. So as the 2 power n, which is a non-polynomial, and it is resource intensive. It requires large amount of memory. It requires a lot of CPU processing time to store and process, and large data involves large requirements of storing the solutions. So it's a very intensive in terms of time and in terms of space. Lack of scalability. So it works. For example, you have a very fast machine or a high performance computer, and you can get optimum solution in a reasonable amount of time, under like say 5 seconds for 10 points in a traveling salesperson problem. But when it doubles only, that high performance machine is not going to work. Okay, fail to handle even modestly sized inputs due to their inability to scale effectively and efficiently. And not optimal for large complex problems, because a large complex problem, as I said again, they are going to be taking lots and lots of times. And you need more sophisticated algorithms if they exist, or may poor use of available resources, heuristics for optimization that could reduce the time spent, but of course the quality also degrades. A brute force recursive approach recalculates the same subproblems multiple times, and unnecessary recomputations. And of course lack of flexibility for real-time applications, because real-time applications, one has to have an answer within a certain amount of time, say sub 5 seconds. So there is no as far as I know, there's no machines which can come up with 5 seconds, say for a traveling salesperson with 20 points. So next time you like try to break into your own house without a key, you should be careful. So what are the practical examples of brute force in real life? So that was the theoretical aspects. This guy has a very sad face. So, what are the practical applications? Is password cracking, cryptography. So, for example, you can look at the numbers over here. So, if I have a password which consists of say 16 positions or 16 digits, alphanumeric characters with special character, you can basically count how many possibilities are there. So say for example, if there are 10, so you can see I can have 10 characters, 10 positions, then I have alphabets also, then I have special characters also. So that's a very large number. So the only way to guess, is no guessing, is to try all possible possibilities. That is password cracking. Then is the cryptography. So brute force approach will require, so if you have like 128 bits long, they require 2 power 128 operations. So that's a very large number. And of course, you need it's a viable attack method. So you need powerful machines to perform this attack, and you don't have such machines at home. Then is the traveling salesperson problem for small data sets. Of course, that's a practical scenario. There are different delivery services, postage delivery, items delivery, and maybe there is other traveling issues also and problems. So that for such problems, traveling between say 15 points, 20 points, so that is a real problem to save time and to save the gas and of course the labor charges also. So it works for 5 to 10 cities, but beyond that, it's not viable. Then is the combinatorial problems for the knapsack problem. It's not the fractional one. So you have say 10 items, and you have to decide that which set of items is going to fit in. So basically, you try all 2 power n possibilities, and then of course you will know that which is the best combination of the items. And of course, there are other graph traversal also, exhaustive search in machine learning, model tuning. Basically, model tuning is finding the hyperparameters based upon which the model gets provides the best response. So the brute force approach is to the combination of parameters on the model and check the results, and the best result is the one which is based upon the exhaustive search. So these are some of the applications of the brute force approach in real life. And with this, we end the basics topic.